Hello everyone, this is Miss Chelsea and today we will be discussing negative exponents. Our lesson objective is that students will be able to manipulate expressions containing negative exponents. Let's start off with an example, m to the third divided by m to the eighth. First, let's expand the expression, so m to the third is m times m times m, and m to the eighth is m times 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 m. We're going to simplify the fraction using cancellation, so we're going to get rid of 3 on the top and 3 on the bottom. We are left with m times m times m times m times m on the bottom. But what is on the top? Well, in this case, the top is 1 because the multiplicative identity is 1. On the other hand, we can use the quotient rule on m to the third divided by m to the eighth. Doing so, we actually get m to the 3 minus 8, or m to the minus 5. Notice how, in one case, we have 1 over m to the fifth, and in the other, we have m to the negative 5. That leads us to our negative exponent rule. The negative exponent rule states that the negative exponent of a base is the same as the reciprocal of the base raised to the opposite, or positive exponent. So, a to the negative x is the same thing as 1 over a to the x. In our example, we saw that m to the negative 5 was the same thing as 1 over m to the fifth. Let's go ahead and try another example. We are going to do 10 to the minus 3 power. First, let's write the expression with a positive exponent. 10 to the negative 3 becomes 1 over 10 to the third because we're going to have the reciprocal base, so 1 over 10 instead of 10, and the exponent is going to change signs, so positive 3 instead of negative 3. Next, we're going to calculate the value of the exponent as a decimal. 1 over 10 to the third is 1 over 10 times 10 times 10, or 1 over 1,000, and 1 divided by 1,000 is 0.001. Now that we've discussed negative exponents, let's look at zero exponents. Our second lesson objective is that students will be able to find the value of an expression whose exponent is 0. Once again, let's start off with an example, z squared divided by z squared. First, let's expand the expression, so z squared is z times z, and we're going to put that on both the top and the bottom. Now, let's simplify the fraction using cancellation. So we are going to cancel 2 z's from the top and 2 from the bottom, leaving us with no z's. Now, remember, we are working with division, so when we look at multiplying and dividing, we use the multiplicative identity, which is 1. So what we really have is 1 divided by 1, which just simplifies to 1. Next, let's use the quotient rule on z squared over z squared. Doing so, we get z to the 2 minus 2 power, or z to the 0 power. That means that z to the 0 power is the same thing as 1. This leads us to the zero exponent rule. The zero exponent rule states that any non-zero number raised to the 0 power is 1, so a to the 0 equals 1. This is the same thing as what we just saw with z to the 0 equal to 1. Now let's look at an example, 5,280 raised to 0 power. We are going to write this expression in standard form. Using the zero exponent rule, we get 1. Now, Tina said that the answer to A is 0. Explain why this is incorrect. Although 0 is the additive identity, we need the multiplicative identity of 1 since exponents are based on multiplication. Thinking about this in terms of the first exponent, 0 times 5,280 would be 0. However, 1 times 5,280 would be 5,280, which is 5,280 to the first power. That's all for today, folks.